Today we are going to discuss about real-time applications in cloud and fog computing. And this is my research area. So first we will see what is cloud. So cloud, it is defined by NIST. So the standard definition I am presenting now. So it is a model for enabling ubiquitous, convenient. So what we mean by ubiquitous? So it is anywhere, everywhere. It is available anytime, and it is conveniently available, and then on demand to an on demand access. So whenever we need, we go for such computing resource, and this computing resource, it may be any network, so maybe even some LAN or WAN connections or servers. So in such cases, it is an infrastructure as a service, and storage, applications, and services. So any of this. So it is considered to such computing resources. We are trying to get an access, and those resources should be rapidly provisioned, as well as it must be made available to the end user with minimal effort, or and with some simple interaction. Cloud computing is. So, what this cloud computing mainly, what are the main essential characters that define this cloud computing? So, first one is it is an on-demand self-services. So, why this cloud came to existence? So, initially, that is the internet bandwidth has enormously increased. So, if you look back some 25 years back, so the internet speed would be only in some kbps. So, but if now it is gigabits, okay, for an institution and all is very common. And we are able to get the service, and as well as the another main technology behind that is virtualization. So with virtualization also, we are able to get the services. We can share the resources where big data centers can be shared efficiently, and to what so the, that is so it can be on demand self service, it can be provisioned, and we are having resource pooling is that. So the big data centers are categorized with the different virtualization technique to the different types of VMs, or different storage servers, like that. And we have broad network access and rapid elasticity. So initially you may start with a small VM, and we can just expand it. Or even the storage services also, you can initially start with some small storage service, and maybe some 10 GB, like that we may start. And later we may simply expand it. So that's a scenario, and it is a measured service. Why? It is a we have to pay for what we are using. So like our phone calls. So for the nowadays, it is we are having unlimited services. So, but previously, if you take there is a postpaid services and all. So, for the time for which we are using, so we have to pay for it. So that is we are having a measured services. So these are the main characteristics of cloud. And what are the deployment models of cloud? So we have four main typical models. So it is public cloud, For example, if you take the Amazon Web Services and all, it is a public cloud, so it is on a public basis, anybody can access. And a private cloud, that is if for any institution or any organization or any company, they want to have a separate cloud for themselves. So then they create a private cloud, and there are so many tools available for that also. And then community cloud. So community cloud actually, for example, if a research community, so they are doing some research on some DNA sequencing and all. So they for that they need more computing power, and specifically for that community they develop or maintain a cloud, and then hybrid cloud. So it is a combination of any of this, a public and a private, or a private and community cloud, like that. A combination it comes. So it is the hybrid cloud. And so initially I told with the standard NAST cloud definition. So they gave this reference architecture. So this is the NAST standard reference architecture. So normally in networks we have this OSI layer. So similarly here, this is the cloud computing architecture. So we have five main roles. There is a cloud consumer, so those who use the cloud services, and then a cloud provider, so the one who provides the cloud services. And there may be, for certain cases there will be cloud broker, so an intermediator who comes in between this cloud consumer and the cloud provider. And then you have a cloud auditor. So for example, in some cloud services, since it is a third party service, so sometimes for delegating some secured services and all, so it has to be audited properly. So in such the cases comes the cloud auditor, and then you have the cloud carrier. So that is the communication medium and other thing that facilitates this cloud services. And in the cloud provider, basically provides software as a service, platform as a service, and infrastructure as a service. And in the service management, so they support the business as well as provisioning or any configuration thing they have to manage, and portability or interoperability. That is, for example, if we use Google Docs, so I can download the document to my Windows format. So as well as if I am working in a Linux operating system environment, I can download it to that format also. So I have the interoperability facility also. So the five main actors: cloud consumer, provider, auditor, broker, and the carriers. And to typically understand this, so what was the earlier, the traditional computers? So in traditional computers, we have a processor, a RAM, a hard disk, and a network interface card. So that's a base hardware, and the configuration may differ from system to system. So on top of this, we have an host operating system, and on top of that, we will have some applications. So now this is the traditional one. So, but if we move to that is now this virtualization technique. So now, if I want to have this virtualization, what happens is to the base hardware, that is one and the same. But now, so previously we simply installed the operating system, but now we install this hypervisor or the virtual machine monitor. So now this virtual machine monitor will this virtual machine monitor is responsible for creating virtual machines. So it does some partitioning of the base hardware and creates the virtual machine. So, for example, in this diagram, it shows some two virtual machines. So, actually, this partition is not a physical partitioning, it is a logical partitioning of the underlying hardware resources is done, and on top of that we are going to have some guest operating system, and on top of that we are having some applications hosted. This, for example, this is one virtual machine, this is another virtual machine. So now this is the scenario. So now, so this is what I have just explained. So the traditional software stack, and now this is now we have an hypervisor in between, and it makes the virtual machines, and then we install in each virtual machine an operating system and an application. So like that it goes. So now, uh, so the operations that we can do on an virtual machines with virtual machines. So actually, we need to understand that this the underlying hardware. So it is multiplexed. So among the two different operating virtual machines, and next is so I am using some virtual machine, but I feel now for 1 month I may have used, and maybe because we are paying on for what we are using. So for next 2 weeks, I don't need that particular virtual machine. So then in that case, I can suspend the virtual machine. So that is in some permanent storage, it will be simply stored. And later when I want to resume, I can use it. I can use it. So that is the suspend. And then I have to resume. Um so maybe after some 2 weeks I need it again back. So in such case I will just make use of it again. This is the basic operations we have with the cloud So now, and this virtual machines, how we have some different types of virtual machines, and I just show a particular table, and it may be simply said as micro, small, medium, large, X large, like that. So the CPU core memory, this thing, GB of memory and storage, it will differ. So that's how it is being managed. And in the traditional system, actually, for example, in a phone number, for identifying it, we have some unique identification number. And now we are going with this computer networking. So here we have a virtual LAN, and how it is going to identify this VM. So it is again based on the IP address. So we need to understand that each virtual machine has an unique IP address for it. Okay, so now let us see some applications of that is this cloud. So now when you look at this, actually it is a healthcare application. So now in this healthcare application, what we see, so that is an ECG analysis being done in a cloud. So here in with the patient, so we have the patient is fitted with some ECG sensors and maybe okay the pressure sensors, blood pressure sensors, and pulse oximeter like that. The different sensors is attached with the user, the patients. So now there is a mobile app, so which has some Bluetooth connectivity, as well as it can send the messages over a wireless network to the doctors or anybody. So this is what. So here we have an app. Whenever there is an abnormality in the ECG, the values being fitted in the sensors is analyzed. So okay, so it is a real-time case where this ECG analysis will be done. So on the mobile app, and if it finds some abnormality, so it has to be immediately intimated to the doctor who is actually taking care of the patient, as well as to the hospital, so that the nurses and some ambulances and all may be sent to the patient home, and immediate attention can be done. So this is a real time case. So this software which does this ECG analysis, so it is at the software as a service layer, and we need to have, actually, since it's a patient data, security must be applied, as well as so there's some the quality of service of this computing resources, everything needs to be verified. So it will deal with the platform as a service, and then we basically have an infrastructure as a service. So that is for the cloud resources. So next, another example real-time application which we can see is here we need to do a large processing. So here it is, and multi-processing has to be done. So because it is a large data set, and we need to go with the parallel processing. So here, yeah, micro array data processing. So the task itself, okay, so Cox CS task. So it is which needs to be done in parallel. So a micro array processing is visualized. Another case is the satellite image processing in geoscience application. So from satellites, we will be okay. So the geo stations and all will be the geology department will be getting images, and this satellite images will be sent, and this has to be analyzed, so that what is the update on a moon surface or on the earth surface, whether there is any change in the ocean border, something like that will be analyzed with a satellite image. So that is the satellite image is received, and some local storage is visualized. And here, this Aneka is the software which is going to do the analysis process, and going to give you details, and that may be distributed later. So this is the satellite image processing and applications. And then Dropbox, you may have used this Dropbox services. And here that is here, this is a typical example for storage as a service. So actually, if you want to have your storage, you may use your system where you can store your data. But maybe if it is at your workplace, only at your workplace you can have access to it. So if I move somewhere, I have to use a pen drive or a external hard disk to carry my data. So, but now we may put it in a Dropbox, or we may even Google Drive is a similar example. So what we do is we put the datas in online, and this is being synced. So later you may log in with your mobile also, or from some other device also you may log in. But only thing is, just like you making use of a Google login, we use the Dropbox login, and I will be able to access all the data whichever I have uploaded in my Dropbox account. Another is Animato. So it is a video rendering software. So for video rendering, we need a large or a high performance computing. So actually, normal systems, normal desktops may not support. So we need a high performance computing. So in such cases, we can rely on a cloud service. So here, this Animato is an example. So where they have used multiple EC2 instances, and with that, it is being used. And so next is an example of a network game. So here also, so if it is a multi-game application, so here that is the different servers, multiple servers need to be coordinated and orchestrated. So for such applications also, this cloud based, if that application is hosted as a cloud based application, then handling it is very easy. And next, I have, okay, so we have now this fog computing being emerged. So now in fog computing, what we have is, so it is an advancement of this um, cloud. Actually, in cloud, everything has to be stored with that in the central repository. So, but with fog, actually, the main objective is to reduce the latency. So we focus on reducing the latency here, and uh, so we include an intermediate layer here. So in cloud, actually, we have, it may be some end user devices, or it may be some sensors, whatever it is. So that will be directly interacting with the cloud. So, but now with fog computing, what we do is we have some intermediate layer. So now this is being introduced. So it may be some computational fog nodes. And why we go for this? Actually, we want to have or distribute. So maybe for based on some IoT applications, I need to have some different fog nodes, or based on some geographical location, or that is, instead of depending on a remote cloud server alone, we just focus on having some intermediate service which is near to our area. So that is the idea in fog. So with this, we can reduce the latency. So now here, for example, so now another emerging area is Internet of Vehicles. So in Internet of Vehicles, so this vehicles normally communicate with the roadside units, and this roadside units, maybe you can think of with some servers at some toll plaza and all, and that in turn may be getting connected with the cloud. So, if we are running some application with this roadside unit, so actually it will be easy for the vehicles at a particular area to communicate with that roadside unit. So, if it is a case, so actually consider if this fog layer is not there. So, what will happen? Every vehicle has to communicate with the central cloud server. So there will be a network latency. But now with fog computing, this network latency is reduced. So that is the basic idea. And that's the case. Here we may have some onboard units in the vehicles, and that in turn will be communicating with the roadside units, and that in turn with the cloud layer. So it will reduce the latency. And similarly, so now this case, so it is in a manufacturing industry. So in industries, we may have some smart assembly lines, and the thing is, if in the assembly line, okay, so as the items are getting passed through, it has to be checked for any defect in that part. So it may involve some capturing of images and scanning, or some image processing has to be done whether there is any defect or not. So those requests, uh, if we are having some fog node, an intermediate node, so then it will be easy. That is, we'll have some nearby server, so which may make the process fast. So that is the basic idea. And this is another case where we have smart cities, where we which can be applied for smart cities. So here in smart cities, we have to visualize, that is possibility of CCTV cameras, drone cameras, or some simple remote cameras, or some maybe a Raspberry Pi based cameras with some embedded system may be installed at different points of the cities. And so these cameras are going to give you videos. That's the thing. So, but handling, if we are sending all the videos to a cloud and for processing, so then it is a typical tedious work. So here, what we can do is we can introduce this fog layer based surveillance, where this video summarization can be done. So a pre-processing of the videos that is sent, that is captured by these CCTV cameras or drone cameras, will be summarized, and maybe some frames out of the videos can be defined, and only those frames, instead of sending the entire video with the summarized video, we can send it to the cloud and it can be processed further. So this is something. So initially, first I told you about a healthcare application where the patient is fitted with some ECG sensor and other thing, and the processing is done in the cloud. But now I am telling you about this fog computing. So with this fog computing, what happens is, so the patient, so here note so EEG sensor, okay, at the brain, may be fitted, a blood pressure, heart rate sensor at the hand, and heart rate sensor, okay, and oximeter at the fingers, and a smart band to note the accelerometer and other orientations of heart, and yeah, lactic acid or the glucose level monitoring thing, and an ECG sensor. So we can have multiple sensors, and through an access point, it can be sent to the fog server. And this fog server has some data analytics application. So it receives the sensor data and do the analysis. And if there is any emergency, so then it immediately intimates the hospital, the doctor, nurses, and ambulances, and the immediate actions are taken to the patient. So this is how this fog computing. So this would help in for the patients. Okay. Any questions? Are you?
Thank you so much, madam, for the wonderful presentation. Now, I request dear participants for your queries. If you have, please come away. Dear participants. Sir, Dr. Swanand Shukla, sir. Sir, Dr. Swanand Shukla, sir, would like to ask something. Later you talk, sir, please.
Good evening, Dr. Bhaskar sir, Principal sir, and Prashant sir, and ma'am. Wonderfully, you have explained about cloud and clouding. We are not basically from IT section. I could not get some terminologies of you, but what I can understand that application of this kind of system is wonderful, and what you are talking about the health regard is also wonderful. We can monitor ECG changes, we can monitor BP changes, we can monitor the glucose level changes, and these are the very fascinating thing what I feel. And really, by sitting abroad also we can check my patients conditions very easily. So that is the beauty of this systems what you have said. And thank you for that. Only my question is there any threat of getting data lost? Because very recently some health data was stolen by Chinese people. That was the story, and good amount of data has been gone to them. And mind you, it is a kind of these data are very wonderful for various kinds of research studies and other aspects, and people may take any advantage of such a kind of data if it is going. So is there any threat, or what kind of protections are given to this kind of storage? Thank you, ma'am.
Sir, actually, initially by the year 2010, 11 itself, cloud computing has emerged. And initially, the security is the main problem, sir. So everybody was thinking and asking questions about whether we can believe this cloud computing, whether we can trust. But now they have there are a lot of mechanisms has been included for the security concerns itself. So, and lot of research has been done in the security purpose also. So, actually, one basic thing is a role-based access control. So, this that's a basic fundamental one that is being used in cloud. So, if I want, I just make use of any cloud service. And there is one main thing they have that is IAM, they call it is identity management service. and identity management with that. So who is the owner of any data, and with this role based access control which I told you, no sir. So with that, who are the persons who can view the data or who can edit the data, everything is well defined with that. Only if somebody has, even if you have used this Google Drive and all, you post some Word document or Excel sheet and you want to collect, share it with your colleagues. So then that is it as share with whom and all, and we can define the permits. That is whether they can be editor or just view and all. So this is one simple example where I give, where I can insist. Actually, not only this, for the secure data and all, so there is separate topic cryptography and network security. With that, there are so many encryption and decryption algorithms. So those RSA algorithms or AES algorithms, and with different hashing methods. So, and actually, if I want to have a larger security, maybe I need to pay something more for the security advantages I add to my data. So only that is the thing. But all those security measures are available. So based on our requirement, we have to make use of it. So then our data can be confidential and secured in the cloud. Yes, sir. Hope I have answered your question. So
Yes,
actually,
ma'am. Thank you.
uh,
Ma'am, one more question is there. When there is means national security is also one of the very important aspect.
yes.
So sometimes the enemies are there inside the country, some of them are outside the country. So whether they can use this technology for some wrong purpose. Is there any
Uh,
kind of guarding for this?
sir, actually, it so cloud has now in its matured level, sir. In this case, now this cloud services, they divide it into some regions. For example, US, in US itself, US West, East, South, like that, and Europe, and the data may be governed based on the region where the data center is. So now they have the cloud providers, they have expanded the regions. Even now, previously it is only in Asia. Now we have a data center in Mumbai. So that is, it is governed by the rules of India. So we can just trust. So if um, for secure data, for our data, we can simply select the region of the data center. So we have to select Asia Mumbai region, so that it is inside our country.
Yes, thanks a lot, ma'am. Thanks a lot giving this information. Wonderful information, ma'am.
Okay, sir. Thank you, sir.
Anybody else, dear participants? So thank you so much, Dr. Swanan Shukla sir, for your nice question, and madam, we have clarified it. Thank you so much. Now I request the chief organizer of the series, Honorable Principal Betkar sir, for conclude the session. Please welcome.
Thank you, sir. Okay, sir. Thank you. Welcome, sir.
Thank you, sir. Now I move towards the vote of thanks. Shri Kumarswami Mahavidyalaya Ausa, District Latur, is organized a world record series to. Today we have completed 323rd session of the series, and the topic was very technical, and it is necessary to all the people who work in the technology, and the title was real time applications in cloud and fog computing. Now this topic have presented by Dr. Angela Jennifa Sujana madam, very nicely, clearly in a simple language, and the PPT was very clear, so we understood a lot from the presentation. Really, you covered all those aspects regarding the topic. What is a fog cloud computing? Then why fog computing is called a fogging one, and why? What is the difference between fog and cloud in IoT? Now you covered all these points in your lecture. Also, you explain about the deployment model, then the different references regarding architectures and essential characteristics of cloud computing. So I'm very, very thankful to you, madam. This is new knowledge for us because we are not relevant to the field technology. But it is necessary to know all the people's how it works and the different benefits regarding this technology. So thank you so much. And also thanks the chief organizer of the series, Honorable Dept sir. Also thanks faculty members of my college, Dr. Sanjay Kale sir, Honorable Praveen Utke sir, and others. Special thanks to Dr. Swanand Shukla sir and all those dear participants who join the series regularly, encourages us. Thanks a lot once again to you all. Now you are kind requested to fill the feedback link which is given in the chat box. With the kind permission of chief organizer, I declare the session is over. Thanks a lot once again to you all. Thank you so much.
Thank you so much. Thank you for a good session, sir. It's like this late but never.
Yes, thank you, sir.
Thank you, ma'am. It was wonderful.
Okay.
Your listening to you.
Okay, welcome.
Correct. Correct. And
Hmm.
and as we go on, listening, we will be getting like or doing like we try to do ourselves practically. We will be getting some doubts. I think now listening, we thought like we have understood everything. I don't know. Yeah. Mm. Yeah. Correct. Ma'am, can you share the PPT with us? Mm. Sir, I am in this group itself. Actually, my name is Nagakala Nanjan Good Gopal Krishna. I think I can message you later in WhatsApp. Mm. Mm. Okay, sir. Okay, sir. Thank you so much, sir. Thank you, ma'am.